Types of meteorites. Natural History Museum. It's printed in nhm.ac.uk. Get to know the main groups of meteorites. They differ in the amount of iron, nickel, metal, and what they reveal about the early solar system. There are three main types of meteorites. Iron meteorites, which are almost completely made of metal. Stony iron meteorites. These have nearly equal amounts of metal and silicate crystals. Stony meteorites, which mostly have silicate minerals. Each group can be split into many more classes and types depending on the mineral's structure and chemistry. First, let's look at iron meteorites. Most iron meteorites are thought to be the cores of asteroids that melted early in their history. They consist mainly of iron nickel metals with small amounts of sulfide and carbide minerals. During the decay of radioactive elements in the early history of the solar system, many asteroids melted, and the iron they contained, being dense, sank to the center to form a metallic core. Meteorites from melted asteroids are also known as differentiated meteorites, as they have experienced major chemical or physical changes, solidifying from a molten state. Sometimes they have an iron core and concentric layers surrounded by a silicate mantle and crust. This type of structure is very similar to terrestrial planets, Mercury, Venus, Mars, and Earth, which also have metallic cores. Iron meteorites can tell us a great deal about how the metallic cores of planets formed. For instance, a structure known as the Widmanstätten texture. The bands are formed by varying levels of nickel. They can be a wide variation in the texture and mix of minerals present within iron meteorites, which will produce many groups and subtypes. Stony iron meteorites. Stony iron meteorites consist of almost equal parts iron, nickel, metal, and silicate minerals, including precious and semi-precious gemstones. They are considered some of the most beautiful meteorites. There are two different types of stony iron meteorites, palisite and mesosiderite. The palisites occur as a single crystal, not as a single crystal, but as a cluster. Elsewhere, it can create patterns of veins through solid metal. The scientific jury is still out on exactly how palisite meteorites formed. Some scientists believe they formed in melted asteroids in a similar way to iron meteorites, where dense iron metal sinks towards the center to form an iron core. Palisites are thought to be samples of the boundaries between a metal core and the silicate olivine-rich mantle around it. If this is the case, they could tell us a lot about the formation of the Earth and other terrestrial planets. However, other scientists think there are very few olivine-rich meteorites in the asteroid belt, and too many palisite meteorites for them all to have come from a core mantle boundary. These types of formations may also be formed by impact melting. Meteorites are breccias, a variety of rock composed of broken fragments of minerals or rocks, cemented together by a finer material. The fragments are roughly centimeter-sized and contain a mix of igneous solidified silicate and metal clasts, rocks made of pieces of older rocks. Meteorites form when debris from a collision between two asteroids is mixed together. In the crash, molten metal mixes together with solid fragments of silicate rocks. Meteorites can therefore both record the history of both meteorites and reveal a snapshot of the conditions required for asteroids to melt and form iron cores. Stony meteorites. The majority of meteorite finds are stony meteorites, consisting mostly of silicate minerals. There are two main types of stony meteorite. Chondrites, some of the oldest materials in the solar system, and acrondrites, including meteorites from asteroids, Mars, and the Moon. Both chondrites and acrondrites have many subgroups based on their composition, structures, and minerals they contain. Chondrites, at over 4.5 billion years old, chondrites are some of the most primitive and pristine rocks in the solar system and have never been melted. Chondrites have a distinct appearance, made from droplets of silicate materials mixed with small grains of sulfides and iron nickel metal. Their millimeter-sized granules give chondrites their name from the Greek chondros, meaning sand grains. There are many varieties of chondrite with differences in mineralogy relating to the type of asteroid and the meteorite they came from. Chondrites are the material from which the solar system formed. They have been little changed compared with rocks from larger planets which have been subjected to geological activity. Chondrites can tell us a lot about how the solar system formed. The most basic types, known as carbonaceous chondrites, are rich in water, sulfur, and organic materials. They are thought to have brought volatile material to Earth when it was newly formed, helping to establish the atmosphere and other conditions required for life. Acrondrites. Acrondrites include meteorites from asteroids, Mars, and Moon. They are igneous, meaning at some point they are melted into magma. When magma cools and crystallizes, it creates a concentric layered structure. This process is known as igneous differentiation. The rocky planets, Mercury, Venus, Earth, and Mars, were formed in this way, giving them planetary crusts, mantles, and cores. Acrondrites can tell us a lot about the internal structure and the formation of the planets, including our own.